Hello everyone, welcome back to the GGM YouTube channel. So this week we will be going over different types of averages. So an average is basically a single value, and this includes things like the mean, the mode, or the median, that summarizes or represents the general significance of a set of unequal values, or the central/typical value. So there's many ways to interpret an average. There's no real one way to interpret what is the central, what is the typical value of a set, because there's many ways to think about it. And different types of averages have lots of different types of applications, and they're very useful in finance, statistics, advanced math. Basically all science requires some statistics, so averages there, data science, anything like that. So there are a few types of averages. The mean and the median and the mode are just a few of them. So the mode is basically the number that occurs the most. So if we have a set, whatever number appears the most times, that's going to be our mode. The median is the middle number in a set of numbers that we're ordering. So this set of numbers has to be ordered. Otherwise, it could literally be anything, because anything could be the middle number if it's not ordered. If we have the numbers ordered from least to greatest, then the median is the middle number there. And the mean is the sum of all the numbers divided by the number of numbers. So, for example, if we have this list of numbers, 1, 2, 3, 3, 4, 6, 6, 6, 7, 6 is going to be the mode because there's more 6's than any other number. 4 is the median because it's the middle number when you order them from least to greatest, right? It's right in the middle. And if we add all the numbers together and divide by the number of numbers, so there's 9 numbers in total, so we divide by 9, we're going to get 38 over 9. So that's our mean. And as you can see, all of these are completely different ways of interpreting the average. When we say average, usually we mean the mean. So if somebody just says average, that's probably the mean. But if it specifies any other type of average, then of course you're looking for that instead. And there's also the range. So the range of a set of numbers is the difference between the greatest and least value. So the range of 1, 2, 3, 4, 5 would be 5 minus 1, right? So that would be 4, because 5 is the greatest and 1 is the least. And the geometric mean of a set of numbers is, okay, so again, I say you learned last week, that's for my class, but that doesn't apply to the YouTube channel. But the geometric mean of a set of numbers is basically the nth root of the product of all the numbers in the set, where n is the number of numbers. So if we had our set here, we would do 1 times 2 times 3 times 3 times 4 times 6 times 6 times 6 times 7, and then we would take the 9th root of that, and that would be the geometric mean. So I'm just going to give you a bit of time to pause the video to solve for the averages here. So for some given list of numbers, you can see the list there. What is the median, the mode, the mean, and if I add 5 to the list, what is the median, the mode, and the mean? So the median may be not so obvious for this second question right here, but I'll give you 5 seconds to pause the video. Okay. So we have our list of numbers. So we have 8. So why don't we start off with actually ordering this set of numbers from least to greatest, because that makes calculating the median much easier. So if we order it, we're going to have 2, 3, 4. Sorry, 1's an element as well. Kind of forgot about that. 1, 2, 3, 4. Well, I guess I was kind of tanking on creativity while making this list. But anyway, actually have two 2's, so we have to consider that, you know. Usually in a set it doesn't actually matter, but this time it does matter if you have multiple of a single number. Okay, so we have our set, and this is ordered. We have our ordered set of numbers, or I guess you could say multi-set because there's two 2's and we're counting them separately, but that's a whole nother thing. So we have our set of numbers. It's ordered, right, from least to greatest. And so first let's try to find our median. So our median is going to be whatever's right in the middle. So we have four numbers here, right? And then we have a number that's smack dab right in the middle. That's 4. So 4 is going to be our median. Right? 4 is our median. Okay, what's our mode now? What's our unique mode? So our mode is just going to be whatever number occurs the most. And you can see there's 1, 1, there's 2 2's, and then there's one of every other number, right? So because there's 2 2's and one of every other number, you can say the mode is equal to 2, right? Because that's the only one that this is the one that occurs the most. Next we have our mean. Mean might be a little bit more difficult to calculate just because we have to add all of these together. So if you recall, we have to add all the numbers together and then we divide it by the number of numbers. So how many numbers do we have here? We have 9 numbers. We're gonna add all of the numbers together and then we're gonna divide by 9. So if you just calculate that out, this is gonna be this is 1 plus 2 plus 2, right? This turns out to be 5. 5 plus 3 is going to be 8. 8 plus 4 plus 8. This is all going to be 20, right? And then 20 plus 9, 29, right? And then 29 plus 23 is going to be 52. And then 52 plus 44 equals 96. So we have 96 divided by 9. And if we just simplify this a little bit, because 96 is divisible by 3, we're going to get 32 over 3. And that's our mean. Now here's another question. If we add 5, right, if we add 5 to this list, what's going to happen? What's our mean, median, and mode? So just going to write it up here with 5. So what's our median if we have 5? Well, if we have 5, that's going to go right here, right? It's going to go right in between 4 and 8. And the reason I said the median is a bit tricky here is because now we have 10 numbers. And that's an even number of numbers. And the reason why that's an issue is because 4 and 5 are both technically in the middle. You can't decide between which of these are actually the middle number. So what do? Well, you just find the mean of these two, right? You just find whatever number is right in between these two numbers. So that happens to be 4.5, right? So just whatever is right in between. So clearly this is just finding the mean is just 4 plus 5 over 2. Right, we have two numbers here, we just add them and divide, and we have 4.5. So our median is 4.5, which I'm kind of mixing fractions and decimals, but that's okay. Our mode is going to still be 2, right, because we still have one of everything else, every other number except 2. There's 2 of those. Maybe it was a mistake to put 2 2's. I don't know. Maybe I should have done 2 4's or something like that. And then our mean, well, we added everything up already to 96, and we just have to add 5, right? It's going to equal 101. And, of course, this is going to turn to 10, right? There's 10 numbers instead of 9 numbers now. So the mean is just going to end up equaling 101 over 10 is equal to 10.1. So these are our answers. So here's a few AMC problems involving averages. Shauna takes 5 tests, each worth a maximum of 100 points. Her scores on the first 3 tests are 76, 94, and 87. In order to average 81 for all 5 tests, what is the lowest score she could earn on one of the other tests? And we also have 4 numbers are written in a row. The average of the first 2 is 21, the average of the middle 2 is 26, and the average of the last 2 is 30. What is the average of the first and last numbers? So I'll give you 5 seconds to pause the video and solve this. Okay, so let's start with the first one. So we have here that Shauna takes 5 tests, okay, and each one is worth a maximum of 100 points, all right? So the scores on the first 3 tests are 76, 94, 87. And she wants to average 81. So when she says average, right, remember average usually means the mean. Unless they specifically talk about any other type of average, we're talking about the mean here. Okay. So our other 2 tests are going to be x and y, okay? And she wants to average 81. So what is the lowest score she could earn on one of these, right? What is the lowest score? And let's just say x is greater than y. It doesn't matter, right? Let's just say x is the bigger one. And so we're trying to minimize y, basically. We're trying to make that as small as possible, right? So what do we know? We know that the mean of this set of 5 numbers is going to be 81, right? So 87 plus x plus y over 5, because there's 5 tests in total, right, is equal to 81. So if we just calculate that out, we have what, 405 equals 76 plus 94 plus 87 and plus x. And if we just add these together, we're going to get this is 170. Adding these two, we'll get 257. And we can find that x plus y is going to be equal to wait, cut this out by 148. Right? Okay. So if 148 is equal to x plus y, then if we want to minimize y, then we want to maximize x, right? However, we know that the maximum x can be is 100, right? So this is equal to 100 plus y, and then y is going to equal 48, and that's our minimum. So the minimum thing she can score, minimum score is 48. We also have our other question. So the average of the first 2 numbers of, okay, let me make a new page. So if we have 4 numbers written in a row, right, so let's say x, y, z, w. And we have the average of the first 2 is 21, so x plus y over 2 equals 21. Remember, we're talking about the mean here because it just says average, so it's implied that it's the mean. Average of the next 2 is, oh, sorry, my 2 looks a lot like z. Sorry. Y plus z over 2, right, is the average of those. That's equal to 26. And the average of the last two numbers is 30. So z plus w over 2, yeah, is equal to 30. So we want to find the average of the first and last numbers. So what is x plus w over 2 is what we want to know. So at first, you'll realize that you can't actually solve for the exact values because we only have 3 equations and 4 variables. So we have to somehow find what this is without finding out what x, y, z, w are, right? So we can start with just multiplying both sides by 2. So we have x plus y is equal to 42, just to simplify things for us, just to make things a little bit easier to see. So that's going to equal 52, 60. Nice. And now we can do sort of a trick here. What we can do is we're cutting this out of the video. We can add the first and last equations, and we're going to have x plus y plus z plus w is equal to 102. And the thing is, we know that y plus z is equal to 52, right? We want to know what is x plus w. So we want to take away y plus z, and we just so happen to know that that's 52, right? So this is going to equal 102, and we're going to get that x plus w is equal to 50. So 50 over 2, well then that's just going to be equal to 25, right? So our answer is 25. And you'll see that if you actually plug in numbers for this, it works. Like I can put any random numbers I want here to satisfy any 4 numbers x plus y, x, y, z, w that satisfy these 3 conditions, and the average of the first and last will always equal 25 no matter what. Like I can have x equals 20, y equals 22, I guess, right? And then the average that would have to be 26, so z would equal 30, I guess, right? And then w would also have to equal 30. And then you can see the average of these two, that's going to be 25, right? So no matter what numbers you choose, as long as they satisfy these 3 conditions, this will also be satisfied. So many distance, rate, and time problems are going to involve average. Let's just not do that. Okay. So that's pretty much it for this week. There's not that much to say on averages, but yeah, that's basically what we have. And thank you for watching, and I'll see you all next week. Bye.